All right, let me put my vodka down for a minute, and then we can get going. Wow, we are almost done today, and then we can all go drink. Isn't that wonderful? Thank you all, those of you who have stayed. Thank you very much. And, Brian, I thought you used to like me, but you've now made me follow everybody else, and the talks were incredible. I learned so much. Spleens were vented, and it was glorious. And as a vendor, I have to thank Regina and say, yes, absolutely. Put vendors' feet to the fire. The problem is, as a CISO, either you can try to put every rip-stitching thing in your contract, and if you forget something, they go, well, you didn't say we had to encrypt view state. Or you can go the other way and just say, don't do stupid shit with your code. And then, see if you can enforce that. So it's a very, very difficult thing to try to do. I was here at IrisCon in 2018, and I talked about trust then. Trust has been a theme throughout the day today, because you can't really have human factors without trust. And I'm going to talk about trust again, because it's been 8 years and things have changed. So let's look at a few things. We have a lot more fake news than we used to have. We have civil unrest. I don't think anybody thought about how invasive and pervasive the overly broad collection and reselling and monetization of data, of personal data has been growing over time. And also not just not giving out data, but failing to protect it properly. But there's been one really big thing that has come up recently, and you all know what it is. It's AI. And, I have a lot of opinions about AI. I'm not going to go into all of them, but I will say a couple of things. Who here has heard the phrase something to the effect of, if you don't embrace AI, you're going to get left behind? Yeah, that's just about everybody. You're going to lose your job. You better get on board this train. For those of you who are here this morning, you remember what Jenny said about the use of urgency and fear in social engineering? What do you suppose? No, I won't go there. But this sort of messaging, like, oh my God, you have to hurry and get this. We're going to be left behind. We're going to lose out. This kind of fear, to me, is new. I've been in tech for 40 years, actually 50 if you count when I learned how to program. And I have never seen the advent of a technology before that created so much instant ambivalence, so much instant controversy. I mean, nobody, there wasn't an equal number of people who said, oh, the internet is crap, we should absolutely not have it. So I wonder what it is that this is kind of unprecedented, that this sort of technology is just so controversial as opposed to just about everything else that has come out, in decades. So, yeah, AI is a difficult thing to deal with. And it does erode trust, but for some other reasons, we've heard a lot of reasons today. But one of them is that anything that we are doing with natural language tends to make us, it tends to activate the parts of our brains that socialize. We are inherently social beings, and there are some researchers who believe that our brains have grown to the size that they have in order to enable us to build social connections with each other and build societies the way that we have. And so when you see something interacting with you in natural language and you're talking to it and it's talking back, something in your hindbrain says this is a person. And you ascribe to them everything that you have learned, that you've grown up learning to ascribe to a person, how to handle a person, which is why I think we are seeing so many disruptions, so many poor people who have been talking to in natural language to these models, and as a result have been, based on what they're hearing, and they're not really judging. They're interpreting it with a different part of their brain, and it is leading people into tragedy. It's also because we inherently tend to trust it more, we forget that it's just software. It is just software. Let's not get too excited about this because it is still just software. It was written by humans, and let's face it, we're not that good at writing software. We're really not. So the problem with dealing with trust has become a much more complicated issue than it was before. So data is both the attack vector and it's our means of defense. And I'll start talking about a little bit of that. One thing that I don't think we're seeing enough of yet, not that I want to see more, but I think there is more coming, is the issue of integrity attacks. We concentrate in security a lot on availability and confidentiality. We don't think about integrity. And also imagine it's really hard to prove a negative. So you can just go and accuse a company of having a breach, and it's really hard for them to prove that they haven't. And I've seen this happen a couple of times now. So when we get to integrity, please do not say blockchain. Blockchain is usable for a few use cases, but it is not the answer to data integrity attacks. I mentioned it being really, really hard to prove a negative. Those of you who saw this in 2018, somebody accused the Bitcoin blockchain of harboring child porn, and it was almost impossible for them to prove that no, it wasn't. There's no way that it could be on the blockchain. You could not store those any kind of images on the blockchain. Also, I really loved this article from Michael Lee, who talked about how he spent time leaving his laptop in a hotel, and when he came back, trying to figure out whether it had been tampered with. And he could not prove it to his own satisfaction that it had not been tampered with by some sufficiently sophisticated attacker. Again, you can't prove a negative. It's really hard to establish trust when you can't do that. Integrity attacks can be less noticeable than just outright denial of service. Imagine, let's just say you're working for a legal firm. If you are an attorney, you know how difficult it is, or how disruptive it can be, even to get the punctuation wrong in a contract. It's got a comma someplace where there shouldn't have been, and it changes the meaning of what you said. Can you imagine how many billable hours it would cost if you called up a legal firm and said, we changed a few of your contracts. We're not going to tell you where unless you give us money. And even then, we might not tell you everything. Imagine how many people you'd have to put on rereading everything, reinterpreting everything against the law. That is cognitively very expensive to figure out if they changed something that is going to be substantial. So thinking about how expensive that would be, or if, they break in and they change the recipe for your favorite frozen dinner, or something. They double the amount of salt. I don't know. Something like that. Doing that sort of corruption is very, very difficult. You need to know, first of all, because data is dynamic and it builds on other types of data and everything trickles down, you kind of have to know when it was changed. and then figure out what was changed. And you're going to have to unwind this at some point and figure out where it started and what it affected downstream. So it may need to be revalidated at scale. And this is what really, really concerns me, really scares me, because, yes, we have ransomware now that's, either just encrypting stuff or it's publishing it. It's a confidentiality attack or it's an availability attack. It's not an integrity attack yet. So, maybe we shouldn't be recording this in case somebody gets an idea. The fraud department might not care about non-financial data. When I was working for the retail ISAC, and this was years ago, it was a much bigger problem where if there were compromises, if somebody compromised somebody's credentials, the fraud department didn't care until they got to the point where they were trying to execute a transaction. Then they cared. But just, having accounts compromised in retail in and of itself was not interesting to the fraud department until a transaction was involved. And businesses tend to be in silos, or as I like to call them, cylinders of excellence. You have to, you may have a department that is sending you data overnight. Let's just say there's a cron job. You're accepting what your other internal department is sending you. You're not validating it, again, as if it were coming from, somebody on the outside. You're inherently trusting it. The other thing is that, remember big data? Whatever happened to big data? I guess it got big enough or something. But, it didn't include inventory, which is why I like to say, thank goodness for GDPR. Really, because it made businesses look at what they have and why they have it and whether they can get rid of it. This is really, really important. I want to say just a couple of things about dark patterns in UI design. People are more aware of it now. But I love this old tweet from Cory Doctorow where he talks about how these scammers made something that looked like a speck of dirt in their banner so that you would think it was on your phone and you would click the banner while trying to erase it. Can everybody spot where the smudge is? It's right there. Boy, that's annoying. That's really, really annoying. There are lots of different dark patterns that you've probably seen in websites where, they do a bait and switch on what you're looking at. They do confirm shaming. Would you like the orphans to starve? Yes or no? And or misdirection. You think you're going one way, but you're trying to click through a sequence that you are used to seeing, and yet they've changed it so that you end up buying something that you hadn't intended to. Roach Motel, where you go all the way down to a transaction and you can't get back out again. The back button doesn't work. Or trick questions like, do you not want to not do cancel the thing? And you go, what? Or ask me later. That's the new thing. Ask me later instead of no. Just don't make me do this. We have been conditioned to expect certain types of UI design. When my oldest was a kid and they couldn't even read yet, they must have been about 3 or 4, we would let them play on a kid's website, and we found them one day in the middle of downloading a browser plugin. And and they were just sitting there and they didn't know what to do. We figured out that in the past, they were used to seeing a UI. When a panel popped up, there would be 2 choices and one of them would be outlined darker than the other one because that was the default choice. And they learned when they clicked on it, it would make the panel go away and they could get back to what they were doing. But when they were in the middle of downloading and installing this browser plugin, they got to the EULA panel and there was no default highlighted choice. So they didn't know what to do. They couldn't read it. They didn't know what to click on. But they had been conditioned for this particular UI, and they didn't even have to read the text to know what it was. So we are used to certain colors, tick boxes, order of operations, and so on, and dark patterns can mess with that to the benefit of whoever has set it up. Or they can create anxiety. Remember, we mentioned fear and urgency in social engineering. So the goal is just to cause the user to make a security decision that's not in their best interest. So how can you spot malicious design? Sometimes only designers can spot malicious design like this that go, you couldn't have done this accidentally. This had to be on purpose to do this particular thing. But the problem is we have to live with so many engineering grade UIs, as I call them, that we will see something that's really badly designed, but we won't think twice about it because we're so used to it. We're not even pushing to make things more intuitive for everybody to use. For, as we heard earlier today, vulnerable people, and you can be vulnerable in a lot of ways. Ask me somehow, or sometime how you can be vulnerable even if you are a tech person with 40 years in the industry. But this is making it harder for everybody to trust software. Now, where AI comes in is that AI is concerning itself more with meaning of text and of data. And this is a great example of this. David Sattar was targeted by CyberBearcoat years ago with leaks of email messages that were changed to make it look like he was a CIA influencer. And what they did was they deleted some text. Now, if you have an automated system looking through, it can tell you that there were certain numbers of characters, a string of characters that were deleted, but not what it means, not how people would interpret it. They took a more specific qualifier and they deleted it so that it would read as if it's a Russian investigative reporting project and nobody knows what that actually means. And they think, oh my God, CIA. So this is the sort of integrity attack that we cannot automate the detection of. We have to have somebody review it and go, oh, you could take it this way. Oh, crap. This is manipulation of the meaning of the semantics, not just of the character string. Which brings me along to talking about what I call the chemistry of data. Because we currently understand data in a few ways. By its classification, although people hate classifying data. By its location, whether it's on my phone, whether it's on a server, whether it's in the cloud. Who it supposedly owns it, who has stewardship of it, but they're not the owner for legal purposes. What the format is. What the container is, if it's in a database versus whether it's unstructured data in a Word document. We analyze data in this way, whether it is ASCII or, whether it's binary, whatever. But what we need to add are things like time and things like context changes, like I just talked about with that alteration of data, and also formulas. And I'll tell you what I mean. When I was working for the Texas Education Agency, we had a requirement, according to the U.S. Federal Education Rights and Privacy Act, FERPA, to protect the data that could be used to identify an individual student. And so we had quantitative analysts on staff who would figure out how to sanitize data that we were required legally to give to external researchers, but to make sure they couldn't identify individual students. So we would sanitize the data, we'd give it out to these researchers. They'd go back to the school district, get the social security numbers that we had taken out, and weaponize the data. So there are formulas to data that will change the security requirements of that data, and it could be in an instant. in something that I call a data event. One example is a press release. Let's say you're going to announce Project Biscuit. And so you program your DLP to look for all instances of the word biscuit to make sure nobody's leaking it, making sure it's not being posted anywhere. And so it's confidential until you make the business decision to release the press release, and then suddenly it's the opposite of confidential. You want it to be public. You want everybody to see it. That business decision is the data event that changes the requirements for security for that data. It's the same data. It's in the same place, same location. The only difference is the business decision. Or let's say somebody moves out of a sparsely populated postal code area so that the sample size of the individuals that you're studying drops below a certain threshold. That's another event that you have to be ready for. So statistical thresholds are something that people know a lot about who have to work with this, again, with sanitizing data or making sure to protect privacy. Another thing that we do a lot of now is focusing attention on particular types of data. I think most of us don't care so much if all of our personal data is being harvested as in volume along with everybody else's. We figured, nobody's going to pay attention to me. I'm just one in several hundred million. It doesn't really matter. But what we often do is we then take individual data we collected and then we focus attention on it. And that's a very different action. I believe that we have the right not to be singled out with our data. One example is after the Sandy Hook massacre in the U.S., a journalist went out and collected all the personal information, the names of gun permit holders in a particular county in New York. And they did this right after the massacre. And they published it. Now, the names of gun permit holders was public data. Anybody could have called and gotten it. The difference was they collected it in the context of the massacre. And then they published it for everyone to see. They called attention to it. That was the difference. And again, this is the sort of context that we have to manage as humans. We can't necessarily automate this sort of thing. So focusing on attention on what somebody's doing, where they are, focusing it and placing it, framing it in a particular context, are the sorts of human things that we do with data. Another example is precursor data. If you're in law enforcement, you know that there are certain types of things like, certain types of chemicals that you have no business owning. You have no business possessing because there's nothing you can do with it except to do something bad with it. If you go into a Boots and you buy 10 boxes of pseudoephedrine hydrochloride, it's probably not because you have 20 children and they each have colds and you need a decongestant for them. It's probably because you're going to make meth. So I believe that in the future, we may have a concept like precursor, except with data. And looking at what data organizations collect and say, you have no business collecting this data. You should not be collecting this data. Knowing what you can and cannot do with this, you're a retailer, there is no reason for you to have medical data, or whatever. I think we should be thinking more about that sort of use, these sorts of use of data. So it's important to know your formulas, and there are a lot of organizations that already intuitively understand this. Equities traders understand that when options expiration comes along, the data that was very important to them suddenly is no longer important after the expiration. People know this, they just can't really articulate it, and they can't put it into a security tool to protect it and say, okay, as of this date, we don't care about this anymore. But you have to know how time and events affect it, and you need to know when to prune your data, and importantly, when the business decisions change the security and privacy requirements, and whether we can build security tools that will keep up with that. Because we don't want to have meta thoughts about our data. We just want to do our stuff with it. But we're being forced into having meta thoughts every time somebody does a bad thing with data, or we get into a situation where we don't believe we can trust the data that we're working with, and we don't know how to fix it. How do we reinforce the trust? Well, there are things like, prevention, being very transparent and everything, detection, being able to detect changes to data, and because nobody logs every single read or every single write of a system. It's just too expensive. You can't do that. But what's really important is the ability to correct, to be able to say, yes, this is wrong, which is why you can't use the blockchain. Remember that thing we said about your credit score? Over on this other side, we're going to say that was wrong. Does anybody even notice? No, it's too late. So being able to restore or adjust data is really important for reinforcing trust. And I'll just leave you with one more thought, and that is, and feel free to argue with me. I love a good knockdown, drag out keynote. But I don't believe that trustworthy data and systems can be separated from trustworthy people and processes. I think they all have to go together. So now, do we have any closing thoughts, Mr. Honan? You want to take us out, and then we're going to go drink. So thank you very much.